Oh, good morning, everyone. And I'm so sad you guys are not with me. It is the first day of school. It is what, August? I think it's August 8/31, 2020. Man, I wish we were all together, you guys. So here's what we need to do. So I'm going to record my lessons, put them on YouTube, attach it to Canvas, and have you guys watch it. This is the lesson. And then inside this, I'll talk to you about the homework assignment, which you're going to have to do, okay? And you're going to have to submit that via Canvas. So every day, we will do a lesson. It will be attached. It'll be on YouTube. You just have to watch it and do the homework, okay? So here we go. Today's first lesson is absolute value. Absolute value functions, okay? And if you want to put this in your interactive notebook, that's great, or if you just want to watch, either way, okay? So, absolute values are simply anything that goes in. This is an absolute value symbol. That right there is an absolute value symbol, okay? So let's just go like that. That's an absolute value symbol. Anything that goes in comes out positive. Always. Always. And it's a real handy thing because some things you never want to be negative. For instance, miles, distance, whatever. I always tell the kids if I drive from here to Kashmir, it's 12 miles, but if I drove from Kashmir to here, that's not negative 12 miles, okay? It's because the other direction. So some things have to always be positive. So if it's a function, that's a fancy word for us, for right now, for a graph. We'll get more specific on what that is. For right now, if it's a function, we'll just say it's a graph, okay? Fancy word. So anything that goes in comes out positive. So let's do a t-table. So let's let x equals 0, 1, 2, 3, -1, -2, -3, okay? So if we take 0, plug 0 into the absolute value, okay? So the absolute value of 0 is 0, stays positive. Put in 1, absolute value of 1 is just 1. Anything that goes into here, like the absolute value of 1 is just 1. Absolute value of 2 goes in, it comes out positive, it's 2. Absolute value of 3 comes out positive 3. Okay, that seems really silly, Mr. Davies, but with the negatives it's different. Remember, if you go to the absolute value of -1, it comes out as a positive 1. Absolute value of -2, you plug it in, -2, absolute value of -2 is a positive 2, and absolute value of -3 is a positive 3. Now this is a t-table. Call it t-table because it looks like a T. And then what we want to do is look at these as points. These are actual points of 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, and obviously -3, 3. Okay, these are actual coordinates on a point. So if we had to graph these, let's take a look at it. So, all right, let's go ahead and start with 0, 0. That's going to be right there, right? The point 1, 1 over 1 up 1, 2, 2 over 2 up 2, 3, 3 over 3 up 3, -1, 1, okay, back 1 up 1, -2 back 2 up 2, -3 up 3, there it is. Now, of course, the graph keeps going on and on and on, and there are fractions that we could plug in and decimals, so we're just going to connect the dots because every possible point you can think of is on this graph. Okay? So the graph looks like this. This is what we call the parent function. So the basic, this is it. If I said, what is the graph of y equals absolute value of x, that's it. That's the parent function. That's the most basic function. But what we're going to do with it is take this absolute value of x on example 2, and we'll go absolute value of x minus 4. Okay, well, we could do a t-table again. That'd be a pain. What would be easier, though, is just take our parent function and move it down 4. So, how do you move it down 4? This point, that's like a vertex. Okay, think of that as a vertex. And we're going to take this point and just move it down 1, 2, 3, 4 for this graph. All right, so I'm going to take my graph, my absolute value graph, and I'm going to move it down 4. 1, 2, 3, 4. Okay, And I'm going to put the same exact graph as what we had above. Put my parent function right there. So here's my parent function, just moved down 4. Okay? If this had been a plus 4, I would have taken the whole thing up 4. So it's just that easy, okay? This is the absolute value graph. All right, turn the page. Now, let's talk about domain and range. It's super important for math classes coming up, especially if you hit pre-calc and calc. You better know what the definition of domain and range is. So domain is all possible, you will have to know this, x values, okay? Or sometimes we like to say how wide. How, can you see that? Hopefully you can. How wide. Okay. The range is all possible y values. Okay. All possible y values. Okay. Or how tall. Or how tall. Okay. So if we know that, real quick, let's take a dance back. How wide is this graph? Forever wide. So the domain of this function is everything. So we're going to say the domain of this one is x equals, and we're going to say everything. But to say everything, because forever wide, every possible x, we're going to say all real numbers. Okay. Same thing with this one. Forever wide, right? Domain x equals all real numbers. Okay. Now let's go back to the range. Okay, the range is all possible y values, or how tall. Well, this one doesn't have anything down here. How tall? It starts at 0 and goes up, right? And it's all possible y values. So we're going to say the range on this one is y is greater than or equal to 0. It starts at 0 and goes up. On this one, it starts at a height of -4 and goes up. So on the range, we're going to go y is greater than or equal to -4. How tall? Reach for your range. How tall? Starts at -4, goes up. Starts at 0 and goes up. Now, let's go back to this graph. Okay, so first of all, example 3. First of all, let's graph it. Now, because of the 2 here, let me highlight that for you so you can see that. Because the 2 right there is going to be twice as tall. So it's twice as tall. We take our parent function. So our parent function, we're going to make it twice as tall. So I'm going to do 2 things. First of all, let me graph our parent function so you can see it. Here's our parent function. You don't have to graph the parent function, but I'm going to put it in there. There is our parent function. Okay. We're going to make it twice as tall, and we're going to bring it down 4. So I'm going to bring it down 4. All right. So let's bring it down 4. So I'm going to go down 1, 2, 3, 4, and it's going to be twice as tall. So instead of 1, 1, it's going to be twice as tall. See how it's twice as tall? It's a vertical stretch. Twice as tall, twice as tall. See, it's a vertical stretch because of the 2 right there. Okay? Vertical stretch, so it's twice as tall. Okay, so I'm just going to go ahead and draw in my absolute value function. Nope, did I miss a point? I do that occasionally. Okay, now, domain. Well, how wide is this graph? Well, it's forever wide still. So the domain is x equals all real numbers. Okay. Now there's a symbol for all real numbers, and I like to use that instead, and it's the cursive R. I like that instead. Too many words to write. The range, well, it starts at a height of -4 and goes up, which means the y value, range is the y. Y is greater than or equal to -4. Okay. All right. Now, example 4. Okay, we're almost done, but let's keep going. I've got 2 more examples and I'm done, right? So, example 4. What I'm going to do is this. It is going to be twice as tall. I know that. So it's going to be twice as tall. So it's going to be a vertical stretch. And we're going to go down 4. We're going to take it down 4. Because of the negative 4. But now this plus 3 is on the inside. So you go the opposite direction. And there's a reason why. We're going to talk about why we're going to do this. So we're going to take our vertex. We're going to think about our vertex. So our vertex is going to be opposite. Let's see if I can write that down. So it's going to be the opposite of this number. Always opposite. It's going to be the opposite of the inside number, negative 3. And then down 4. That's where my vertex goes. Okay, it's always the opposite of this number, and I'll explain to that to you in a second. So I'm going to go negative 3. So my vertex is going to be at negative 3. 1, 2, 3, 4. Okay, opposite of this number on the inside. That's a horizontal shift. Okay, that is a horizontal shift. Okay, so now it's twice as tall. So up 1 over 2, it's a vertical stretch. Up 1 over 2, it's like slope. Up 1 over 2, up 1 over 2, and the same thing over here. And then there we got it. Go like that. And go like that. Okay, there it is. Now, why is this at negative 3? Because negative 3 for x zeroes this out. That's why. Negative 3 for x makes this 0, which puts it at its lowest spot. Okay, back to domain. How wide is this? Well, it's forever wide. So all of these, every single absolute value graph, hopefully you've realized the domain is all real numbers. The range starts at a height of negative 4 again. Y is greater than or equal to negative 4. Okay, now, it says on your own, you can try it. But let's see if you can figure this out. We're not in class, so I can't have you do it on your own, but we'll try and do this together. So here's what I know. This thing's going to be half as tall, which means it's going to be a vertical shrink. It's going to have a vertex, okay, at positive 2, remember opposite, at positive 2, positive 5, okay? Opposite inside. So let's go to positive 2 and positive 5. 1, 2, 3, 4, 5, okay? Now, let's graph it. So it's going to be half as tall, okay? So it's going to be like a slope. It's going to go up 1 over 2. See that? Up 1 over 2, 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 and then I'm going to graph it in. Okay, and there it is. Now, domain, oh, what do you know? It's forever wide. So the domain is x equals all real numbers. Capital cursive R means all real numbers. Let's look at the range. Starts at a height of 5, doesn't it? Height of 1, 2, 3, 4, 5. So I'm going to say the range is y, and it goes up. Y is greater than or equal to 5. Okay, so here's what I want you to do. So for the assignment, when you look at the Canvas assignment, you got page 6, 1 through 4. Okay? And if you do just this basic 1 through 4, you get a B. Now if you want an A, there's an additional problem that is on Canvas that you have to show me if you want an A. Okay? Homework is worth 50% of your grade. So, or I'm sorry, 40% of your grade. So I would suggest you do it. Okay? If you have any questions, email me. We can do a Zoom here in a couple of days. Hopefully that makes sense.